Next is what is hybridization. So hybridization is basically is the mixing of atomic orbitals so that each have some character of each of the orbitals mixed. So Amra first we'll watch a video and then we'll come back to hybridization.
Hello and welcome to a video about hybrid orbitals, often called valence bond theory, developed in the 1930s by the great chemist Linus Pauling as a model of bonding to understand the three-dimensional placement of atoms in a molecule, and that is critical to our understanding of the properties that molecules have. In this video, we will look at methane, ethene, ethine, ammonia, and water as our models for hybridization. There is only a small group of atoms in the second period that the model really works for, but among those are carbon, nitrogen, and oxygen, which make up the vast majority of molecules that exist on Earth. So the model applies to a limited number of elements, but it applies by far to the majority of molecules. Let's take a look at the word hybrid. It is a blending of two varieties. If you get a horse and donkey together, you get a mule, a blending or hybrid of a horse and a donkey. Let's get to hybrid orbitals using carbon as our model. As a single atom, not bonded to anything, carbon has 2 electrons in 1s, 2 electrons in 2s, and 2 electrons in 2p. This electron configuration is the energy arrangement of carbon's electrons. However, carbon rarely exists in nature as an individual atom, except momentarily while undergoing chemical reactions. Carbon exists with its valence electrons bonded to other atoms. When carbon bonds to 4 other atoms, carbon's 4 bonds are experimentally seen to be equivalent. And so when the carbon atoms finds itself in a bonding situation, its bonding electrons themselves exist at equivalent energies, which requires that they hybridize to an energy that is intermediate between the 2s energy and the 2p energy. Or you can think of it as a blending or hybridization of the two energies, the s and p energies. And since the energies of these electrons have now changed, the shape of the orbitals they occupy are different as well, which we will see momentarily, and those are called hybrid orbitals. They are named 2sp3 hybrid orbitals. The naming often trips up students, so before we go any further, let's take a look at where the 2sp3 name comes from. The 2 comes from the second principal energy level that the valence orbitals are in. The s comes from the 2s orbital contributing to the hybridization, and the p comes from the 2p orbitals contributing to the hybridization, and the 3 comes from the number of 2p orbitals used in the hybridization. Once hybridized, the 2s and 2p orbitals no longer exist, and so we have 4 2sp3 hybrid orbitals. 4 2sp3 hybrid orbitals derived from combining the energies of 1 2s orbital and 3 2p orbitals, which gives a total of 4 2sp3 orbitals. Before we look at the shape of hybrid orbitals, it would be helpful to briefly review the atomic orbitals. The 1s orbital is a sphere, the 2s orbital is a larger sphere surrounding 1s. And here we will get rid of 1s since we are only concerned with the valence electrons. Each 2s orbital is a 2-lobed shape converging at the nucleus. So there are the 3 2p orbitals. However, when hybridization occurs, the s and p orbitals cease to exist, and the 2sp3 orbitals have an entirely different shape. We can see that orbital hybridization explains the VSEPR placement of carbon's 4 valence electrons, since all 4 2sp3 orbitals are equivalent. Each 2sp3 orbital repels the others with equal force, resulting in identical bond angles. The carbon atom only hybridizes when it is in a bonding situation. Here, 4 hydrogen atoms bond to carbon by overlapping their orbitals with carbon's hybrid orbitals. So what would be the reason for this? If we go back and see that both carbon and hydrogen have unpaired electrons, the overlap allows the electrons to pair and thus go to a lower potential energy. The illustration here contains the valence electrons of both carbon and hydrogen. And since everyone likes to visualize atoms as spheres, we can do the same. Here is our carbon atom, And here are the hydrogens with the overlapping spheres, indicating the overlapping orbitals that constitute the bond. The bonds are more readily discernible in a ball and stick model, which also makes the bond angle more visible. Since all 4 sp3 orbitals are equivalent, each bonding orbital repels the others with equal force, resulting in identical bond angles. The bonds in hybridization also have their own nomenclature. The overlapping orbitals are called sigma bonds, which represents the single bond occupied by a single pair of electrons. What about double bonds? How does the hybridization model explain double bonds? We will use ethane C2H4 to see what happens in a double bond. The single bonds we know are sigma bonds, and the double bond also has a sigma bond, but the second bond of a double bond is a pi bond. Let's see how hybridization and orbital overlap can explain a double bond. The 2 carbon atoms in ethane are equivalent, so let's look at one of the carbon atoms first. A pi bond comes from the overlap of unhybridized p orbitals, and so the atom hybridizes only 3 orbitals, leaving a p orbital unhybridized for the pi bond. The hybrid orbital is called 2sp2, the superscript 2 denoting that only 2 2p orbitals have contributed to the hybridization. The 2sp2 hybrid orbitals exist in a plane perpendicular to the unhybridized 2p orbital. Let's remove the 2p orbital for now to more easily see that. The 2p hybrid orbitals are spread out at a 120-degree angle, which means that they exist in a plane, and the plane is perpendicular to the unhybridized 2p orbital. So this is what both carbon atoms do when bonding occurs in ethane. Each carbon atom is sp2 hybridized. The sigma bond occurs with 2sp2 orbital overlap. What about the pi bond, the second bond of the double bond? Previously we said that it comes from the unhybridized p orbitals, which we see here from both carbon atoms. The top and bottom lobes of the 2p orbitals overlap above and below the axis of the sigma bond, forming a single pi bond, the space in which the now paired electrons move around. The ball and stick model shows this double bond with 2 dashes. To summarize, sigma bonds occur along the axis between the The pi bond occurs above and below the sigma axis, where the p orbital lobes have overlapped. The molecule also bonds to 4 hydrogen atoms overlapping both carbon orbitals, creating 4 more bonds. With the ball and stick model, we can readily see that each carbon has a trigonal planar geometry, and thus the whole molecule is a single pi bond above and below that plane. Now let's look at how hybridization can be a model for the triple bond using ethine C2H2. The carbon-hydrogen bonds are sigma bonds, and the triple bond is 1 sigma bond and 2 pi bonds. Let's see how hybridization can accommodate this. Since pi bonds come from p orbitals, and we need 2 pi bonds, then 2 2p orbitals have to remain unhybridized, and so the remaining single 2s orbital and a single 2p orbital will hybridize to 2 2sp hybrid orbitals. And there is also the violet 2px and the blue 2py orbitals. Here, each green lobe is a single orbital, and so they each have an electron, while both violet lobes constitute the single 2px orbital with a single electron, and both blue lobes constitute the single 2py orbital with a single electron. The other carbon in C2H2 also has that same triple bond, and so it has the same hybridization. Let's see what happens during bonding. sp orbitals from both carbons overlap, forming a sigma bond. The upper lobes of the blue 2p orbitals overlap, as do the lower 2 lobes, creating the first of the 2 pi bonds. Can you guess where the second of the 2 pi bonds comes from? Yes, that's right. It is the overlapping of the violet 2p lobes. Let's get rid of the sigma bond for a moment to take a look at something interesting. Each pi bond lies on a separate plane, and the two planes are perpendicular to each other, and so the two pi bonds are perpendicular to each other. Finally, two hydrogens will overlap with the remaining sp hybrid orbitals, creating the C2H2 molecule. The overlap of the space-filling model reflects the overlapping orbitals, which is also represented by the ball and stick model. In the remainder of the video, we will look at hybridization of nitrogen and oxygen using NH3, ammonia, as our model for nitrogen hybridization, and H2O, water, for our oxygen model. In NH3, nitrogen has 3 sigma bonds and a lone pair. So how does hybridization account for this? The hybridization is 2sp3, and nitrogen has 5 valence electrons, so one of the 4 2sp3 hybrid orbitals has a pair of electrons. The 3 sigma bonds come from the sp3 orbitals with a single electron, so they can pair up, and so the remaining electron pair is a lone pair, an unbonded pair of electrons. As with sp3 hybridization in carbon, nitrogen's hybrid orbitals spread out in a tetrahedral shape. And lastly, water. Here, oxygen has 2 sigma bonds and 2 lone pairs. In water, oxygen is also 2sp3 hybridized, but with 6 valence electrons. 2 of the sp3 orbitals have paired electrons. You can probably guess that the sp3 orbitals with a single electron will overlap with hydrogen, and the remaining 2 pairs are unbonded. They are lone pairs. Again, oxygen's hybrid orbitals spread out in a tetrahedral shape. That's it for hybridization, the product of a mad scientist. See ya.
Okay, so most of you did not understand 70% of it, I assume.
Yes.
Yes, sir.
Okay, so I shared the video in Came by Navid Facebook group. Okay, so after I explain this, tumra have a look and look into that again. Okay. Acha. So আমরা এখন will study what is hybridization. দেখছো তোমরা?
G, sir.
Okay. Next is key features of hybridization. Number 1, atomic orbitals with belonging to the same energy, level undergo hybridization. Number 2, the number of, so iter example would be J 2s would hybridize with 2p, 3s would hybridize with 3p or 3d, right? So 3s or 3p or 3p or 3d. So hybridization usually takes place with among orbitals of the same energy level. Number 2 is the number of hybrid orbitals formed is equal to the number of atomic orbitals mixing. The number of hybrid orbitals formed is equal to the number of atomic orbitals mixing. For example, if you're mixing 2s orbital with 3 of 2p orbitals. So আমরা জানি যে p has 3, p subshell has 3 orbitals. So if you have 2s with 3 of 2p, then total how many orbitals do we have? We have 4 orbitals, which we write as
2sp3.
sp3 hybridized orbitals.
2sp3 হবে না?
2sp3 লিখতে পারো, হ্যাঁ। Hybridization happens only during the bond formation. And not in an isolated gaseous atom. Okay, next is the shape of the molecule is predicted by seeing the hybridization. So nobody writes anything. First, listen. Okay. First, listen, and then if you have questions, ask me. Okay. So we'll take a molecule. First, okay, number key. What molecule was this? CH4, right? They took an example of CH4, and then they also took an example of C2H4, right? Okay. So Amra, I'll take different colors for it. Okay. So first of all, let's take carbon. So carbon, Amra, let's draw it with a black. Okay. So carbon is 1s2, 2s2, 2p2, which means 1s2 and 2s2 is full. 2p2 would look like this. They have one here and then one here. So we can take this as 2px, 2py, and 2pz. So আমরা জানি যে p subshell has 3 orbitals, a px, a py, and a pz. Why is it px? Because the p orbital, the px has rotation around the x-axis. Py has a rotation around the y-axis, and the z has a rotation on the z-axis. এই জন্য ওরা এক একটা নাম, বাট এটা আমাদের মানে এতটুকু জানলেই হবে. We don't need to know how the rotation takes place. Now, hydrogen on the other hand, let's take hydrogen with a different color. So hydrogen on the other hand has just 1s1, right? So it just has 1 electron. Is everybody clear up to this?
Yes, sir.
Yes, sir.
Any questions?
Yes, sir.
No, sir.
Okay. So if you have seen the video properly, you would see that now carbon and hydrogen are going to form covalent bonds, right? And since the carbon, the first and the second 1s and 2s of carbon is already full, they will not be part of bonding. They will not be part of bonding.
So it hydrogen is one.
Carbon has 6 electrons. If right, carbon has 6 electrons. So this is the first shell. So how first shell koyta electron thake?
2 electrons.
2 electrons. So this has 2 electrons. So second shell has how many?
8.
No.
4.
Second shell
Yes,
has
sir. It's 4.
4. Acha. Out of 4, the S has 2. 2s has 2 electrons, and the 2p has 2 electrons. Are you clear up to this?
Yes, sir.
And আমরা জানি যে when electrons fill up, first they will fill up singly, and then they'll pair, and then they'll pair. Clear up to this?
So কোন axis টা আগে pair হয়?
X-axis. Are you clear up to this?
Yes, sir.
Okay, so now next is, since they have free electrons, since their orbitals are free, and since their orbitals are free, what will happen? They'll mix together. So the 2p of carbon will mix with the 2s of hydrogen.
1s হবে, sir.
Sorry, 1s হবে, sorry. Thank you for correcting me. 1s of hydrogen. So এখন they're mixing together, right? আমরা জানি যে what is the shape of a s orbital? Spherical. What is the shape of a p orbital? Our lobe. This is suppose px, this is py, and this is pz. px, py, sorry, এটা py, এটা px, আর এটা হলো pz. So, and this is s. So how many s is involved?
1.
How many p is involved?
1.
No, p is involved. P is involved একটা, দুইটা, তিনটা. আচ্ছা. Okay, so what happens is here we have an electron in px, we have an electron in py, and we have an electron in pz, right?
PZ and I though.
Sorry, pz and I, but we have an orbital here, right, which is empty.
Yes, sir. Yes, sir.
We have acha. And how many hydrogens needs to be bonded?
4.
So suppose এখানে একটা হাইড্রোজেন আসলো, এখানে একটা হাইড্রোজেন আসলো. Can hydrogen come here?
No,
Why not?
because it doesn't have any electron to pair with.
Better, because it does not have any electrons. Okay, very good. So what basically happens is carbon Initially, carbon has 2s2 and 2p2. So when hydrogen, 4 hydrogens are trying to come in. 4 hydrogens are trying to come in. And do what? And do what?
Bond.
With the valence electron.
And form bonds. Very good. Yes. So what happens is one of the electrons from this carbon gets excited and comes here. So তখন what happens to the carbon? তখন carbon becomes like this. 2s1 and 2p3. সবাই কি বুঝছো?
Yes, sir.
Yes, sir.
Why is this happening? If you people have seen the video, ওখানে ওরা দেখাই দিছে যে carbon has this is the energy level, this 1s2, 2s2, 2p2. After hybridization, they come to a lower energy level. Do you remember? They have shown it in the video.
Yes, sir.
Yes. So what happens is carbon, one of the electrons are repelled. Who's repelling this electron? The incoming hydrogen atoms. The incoming hydrogen atoms. They're repelling one of the electron from the 2s into 2p and finally forming what?
4 hybridized orbitals.
4, no, not 4 hybridized. There it's now this has become a 2s and this has become a 2p. ঠিক আছে? এখন all of them are now singly filled. All of them are now singly filled. So are they now ready to form bonds with the hydrogen atoms?
Yes.
Yes. So now hydrogen, each hydrogen donates an electron like this. Have they all formed bonds?
Yes, sir.
How many S was involved?
Yes.
Carbonate S koita? 1.
1,
P koita?
3.
3.
So that's why this is known as sp3 hybridized. sp3 hybridized or sp3 hybridization. কে বুঝো নাই? আমি জানি যে অনেকেই আছো তোমরা বুঝো নাই। প্লিজ আস্ক কোয়েশ্চেনস।
Naming the sp3 hybridized কেমনে হলো? 4p3 hybridized হলো না?
সরি
sp3 hybridized naming টা কিভাবে হলো? 4p3 hybridized হওয়ার কথা না?
4p3 কেন হবে? this is the second shell, that's why it's 2. And sp3 means they're in this orbital. Ora ki first year they showed us what is hybridization. Hybridization is mixing of orbitals, right? Mixing. And how many orbitals are being mixed here? 1 s orbital and 3 p orbitals are mixed together. আচ্ছা, এখন তুমি যখন mixing করবা, হ্যাঁ, will they still have the same shape?
না,
their shape will also change. So originally S had a spherical shape. P had a what?
why?
P had a hourglass shape. Now since we have a sp3 hybridization, since we have a sp3 hybridization, now they'll have a modified shape, like something like this. ধরো যে এটা একটা s with a p, px, py and pz. Did they show something like this?
হ্যাঁ এরকম ছিল
Yes, sir.
হ্যাঁ,
Video
so
তে।
এটাকে আমি যদি আরেকটু সুন্দর করে আঁকতে পারি, it's gonna be something like this. It's gonna be like a flower, right? And this is a sp3 hybridized orbital. আচ্ছা, আরেকটা জিনিস তোমাদের মনে রাখতে হবে যে when you do hybridization, you will have some characteristics of from both of them. So ওরা first বলছিল if you mix a horse with a donkey নাকি something else,
হ্যাঁ
then you'll have a mule, right? So in a mule, will you have just characteristics of horse or just characteristics of donkey, or will you have characteristics of both? You'll have characteristics of both. Very good. So sp3 hybridization has characteristics of 1/4 s character, 3/4 p character. সবাই কি বুঝছো এটা? তোমাদের 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 হাইব্রিডাইজেশনে the only thing you are expected to understand is যে ওকে sp3 নাকি ও sp2, কিন্তু over the years সবার মনে একটা কনফিউশন থাকে যে what is hybridization, how is it formed. So এর জন্য তোমাদেরকে first thing I did was I showed you a 3D video so that you can actually visualize how this is happening. So did you people understand this now?
Yes, sir.
Okay, so তোমাদের your task would be যে to after this class just remembering all of what I am teaching and just referring to the video again. অনেক easy হয়ে যাবে, ঠিক আছে? আচ্ছা, next is, so does anybody have a question here? Samir, can you please ask? Sir, is the ratio always the same as the one you showed? What ratio? Samir.
মনে হয় 1/4 আর 3/4 এর কথা জিজ্ঞেস করতেছে।
হ্যাঁ, for if it's sp3 hybridization, then so in sp3 hybridization, what portion is s donated? Therefore, in total there are 4 orbitals, right or wrong? In total there are 4 orbitals. So out of 4 orbitals, how many orbitals belong to the s orbital, or how many orbital is s orbital? Out of 4 orbitals, how many is s orbital?
1.
And how many is 3 orbital? Sorry, p orbital?
3.
3. So in total 25% is s. If you take 4 orbitals to be 100%, so 25% is s orbital and 75% is p orbital, right? Right or wrong?
Right.
Right. Okay. Samir, have you understood? Did you understand? Okay, good. Do you have a problem with your mic? Okay. Next is, what about C2H4? So ekhane amra will take 2 carbons with 2 different colors. We'll take 2 carbons with 2 different colors. So one carbon is 1s2 1s2. Please mute your mics, everybody. And 2p2. So this is 1s2, this is 2s2, this is 2p2. Similarly, we'll take another carbon, which is orange. Same. 1s2. Oh, Samir had a question, why are they like upside down? They're not upside down, they're at opposite spins. So that the spins, the electrons always spin in different directions. One spins in the clockwise direction, one spins in the anti-clockwise direction. You know that direction is different. And then this is 2p2. And we have hydrogen. We have hydrogen, which is 1s1. Is everybody clear up to this?
Yes.
Okay. So after the hydrogens come and interact, what happens? This stays as 1s. I'll just redraw it. I'll just redraw it. C2H4, carbon, 1s2, 2s2, and 2p2. One is 2, 2s2, 2p2. Hydrogen plus 1, just 1s1. So next, what happens? So this is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. Next, what happens is the 1s2 stays as it is, but what happens to the 2s2? It becomes 2s1 and 2p3. 2p3. Same for the other carbon. 1s2, 2s1, 2p. Sorry. 2p3. Okay, guys. Here. So if we take this as the black carbon, and this is the orange carbon. Okay. So black carbon is bonded to how many hydrogens?
2 hydrogens.
It's bonded to 2 hydrogens. And how many carbons?
1.
1 carbon. So Amra, we can say that a hydrogen comes here. Okay. A hydrogen comes here. And the carbon. So the black carbon is bonded to the green carbon, right? Sorry, the orange carbon. So this is the orange carbon. On the other hand, how many bonds does the orange carbon form? How many hydrogen is it bonded to?
2.
2.
So there's a hydrogen here.
And
There's a hydrogen here. And this is bonded to the what?
Black carbon.
This is bonded to the black carbon. So how many bonds form? How many bonds form? 1, 2, and 3.
6.
3, right? 1, 2, and 3. So এই যে একটা extra, এই যে এখানে একটা extra পড়ে আছে না? What is this? What is this?
Pi bond.
Pi bond. Pi
This is
bond.
the pi bond. So how does pi bond form? Sideways overlap. Sideways overlap
P
of
orbital.
p orbitals. So do we have two free p orbitals here?
Yes, sir.
Here, this p orbital. Suppose this is the black p orbital. This is the black p orbital, and this is the orange p orbital. Are their electrons bonded or are they free?
They're free.
They're free. So this p orbital and this p orbital will overlap with each other. Will overlap with each other. How?
Sideways.
Sideways, and form what?
5.
Pi bond.
Pi bond.
And form pi bonds. So now have you understand how this is a pi bond, or how pi bonds form?
Yes.
Yes, sir.
So this carbon has how many s involved?
2.
How many s involved?
2.
How? 1. AJ, this is
One,
1s.
one.
1s.
Sir. One.
We take for one carbon, okay? So here there's 1s involved, and how many p's involved?
3.
3.
No, 2. 2. This is a pi bond. This is a free electron, a lone pair, right? When these overlap sideways, they form lone pairs. They form lone pairs. So in formation of sigma bond, how many orbitals are involved? One s is involved and 2p is involved. What is their hybridization? This is a sp2 hybridization.
Hybridize.
Oh my God.
This is sp2 hybridization. Why? Because during this hybridization, 1s was involved and 2p was involved. আরেকটা কি কোভ্যালেন্ট বন্ড ফর্ম করছে? এই যে লাস্টের যেটা, did they form the covalent bond? No. They're free electrons, and they overlap sideways. ঠিক আছে? So in sp2 hybridization, how many orbitals are involved?
3.
3 orbitals are involved. 3 orbitals are involved. So out of 3 orbitals, how many s orbitals are involved?
1.
So 1 s orbital
And 2p orbital.
and 2 p orbitals. So out of 3, so 1/3 is s, 2/3 is p. So what percentage of s characteristics would be there in sp2 hybridization?
33%.
33%. And p? 66 or 67%. Have you understood hybridization?
Yes.
Yes.
স্যার আবার বোঝান তো।
কোনটা বুঝো?
এই রেশিও গুলা বুঝাই না, বুঝি না, আবার একটু বলুন।
Ratio is nothing. Ratio is, for example, in sp3 hybridization, in total you have 4 orbitals. In total you have 4 orbitals. Out of 4 orbitals, 1 orbital is s, 3 orbital is P. So therefore, 1/4 is S, 3/4 is P characteristics. So 25% is X characteristics, 75% is P characteristics. In sp2 hybridization, there are 3 orbitals involved. Out of 3 orbitals, there's one s orbital and there's 2 p orbitals. So in total, there are 3 orbitals. Out of 3 orbitals, 1/3 is s character, 2/3 is p character, which relates to 33% and 67%.
Okay.
Any other question? Any question?
Sir, while counting the s orbitals, yellow carbon s orbital থেকে count করেননি কেন?
sorry.
যখন s orbitals গুলোকে count করলেন তখন yellow carbon ওইটা count করেননি কেন s টাকে?
Yellow না তো, orange.
Sorry, orange
হ্যাঁ,
carbon টাকে।
but তোমাদের the first মানে এই জিনিসটা হলো যে hybridization is only for one carbon. So if you don't want, instead of the black carbon, if you want to take for the orange carbon, so orange carbon is the same. How many S is involved?
1,
How many P is involved?
2,
So what is this hybridization? sp2 hybridization. বুঝছো ওয়াসিমার কোয়েশ্চেন ছিল না এটা?
yes sir.
Next question please.
So triple bond-এর একটা এক্সাম্পল দেখাবেন?
Sure. Triple bond. So I won't do the lengthy process. I'll have a shortcut. This is the black carbon and this is the orange carbon. And these are green. Okay. Acha. Next is the black carbon. The black carbon has 1s2. Acha. Let's just 1s2, 2s1, 2p, 3. So this is the black carbon. And then we have the orange carbon, which exactly has the same thing. 1s2, 2s1, 2p, 3. And then we have hydrogen, which is 1s1. Okay. So how many hydrogens are involved here?
2.
2 hydrogens. So we assume there that this is a hydrogen. This is a hydrogen. This is bonded with a carbon. This is bonded with a carbon. So how many free orbitals are there?
4.
4. Mane 2 of each. This is free. This is free. This is free. This is free. What will happen to them?
Pi bonds.
They'll form pi bonds. They'll have sideways overlap. They'll have sideways overlap. So in forming this triple bond, how many s orbital is involved? For a carbon, how many s orbital is involved?
1.
1.
One s orbital is involved. And how many p orbital is involved?
1.
1 p orbital, 1 s orbital and 1 p orbital. So in total, how many orbitals do they have?
2.
2. So the half is s character and half is p character.
P
So
character.
50% s character and 50% p character. Any other question?
No, sir.
So hybridization is basically mixing of orbitals. সেই mixingটা if it's between s and a s, if it's between s and a s, what type of bond forms? Sigma bond. If it's between a s and a p,
Sigma.
sigma bond. If it's between a p and a p,
Pi bond.
Sigma bond or a pi bond.
head on hole,
উপরে বানিয়েছে
if it's head on,
একটা sigma একটা pi as in carbon carbon double bond হলো একটা sigma একটা pi
if it's head on like this, if it's head on like this, it's sigma bond. And if they are p but they sideways overlap,
Pi bond.
pi bond
they form pi bonds. That's it. And তোমাদের জন্য for you, sp3 hybridization, sp2 hybridization, আর sp আসলেও আসতে পারে, but highly unlikely it won't come. But highly unlikely it would come actually. Unlikely it would come. Whatever. So sp3 has how many orbitals involved?
4 orbitals.
4.
4 orbitals. sp2
3.
3 orbitals.
3.
sp
2.
so 4 orbitals. For example, CH4. What is the bond angle for CH4?
Tell me answer. 109.
109.
Very good. 109.5 degrees. And what is the shape?
Tetrahedro.
Okay, if you have 3 orbitals, what is an example? BCl3. BCl3. What is the bond angle? 120 degrees. What is your shape?
Triangular planar.
Trigonal planar or triangular holo অসুবিধা নাই, trigonal planar. এই তো বুঝে গেছো তোমরা hybridization. আমাদের আর last electronegativity আমরা will start next class hopefully.